squared, and what we learned was we can just replace the x with x squared here, and it will give us a new polynomial for, so what will that be, x to the 4k? Are we happy with that, what I've done there? So x squared and that x is replaced with x squared, so it became x to the 4k. Yes, sir?
What's the title for today?
I already had it up. You should have looked at it then. Okay, so hence, that's it. That's it. You can expand this if you want and have a look at what the polynomial will look like, but you don't have to. Hence estimate. Okay, so I see an integration sign there. So hence estimate was cosine x squared between 1 and 0. Okay, to 4 decimal places. Okay, so instead of using the integration of this, we're now going to use the integration of a polynomial to do the same thing.
How many terms are we going to put in the polynomial?
Good question. So what we're going to do is we're just going to start subbing in. Well, you'll see. You'll start subbing in and you see at some stage, you know the way, it'll only work if it's converging. So we'll see if it is converging. If it's converging, we'll know when to, we'll have a good...
How do you see if it's converging? If it keeps on doing this?
Yeah, so if you start subbing in k is equal to 0, k is equal to 1, 2, 3, 4, and so on, yeah, and each answer is getting smaller and smaller. Yeah, or the difference between each answer is getting smaller and smaller. Okay, right, so how are we going to integrate this? Not this, we're not going to integrate this. You could have a whirl at it with your integration by parts maybe, but we're going to try and integrate it by this. Right, so that means we have to integrate this. We have to integrate a sigma okay. So that's integrating a polynomial, but we just don't write all the polynomial. It's like integrating something like this. It's like integrating this. We would know how to integrate, well, if it's just stopped there, we'd know how to integrate that one. We'd add 1 to each power and divide down. And then we look for what the pattern would be to write it perhaps as a sum. So if we integrated this would be x squared over 2 minus x 4 over, would it be 4 factorial?
24.
Would it be 4 factorial? Yeah, it would be 4 factorial. So you can see that that the pattern would kind of continue in the integration once you have the correct thinking. So we don't actually need to expand this to integrate it. We should be able to integrate it by looking at it here. Yeah.
Does 4 decimal places mean x to the 4?
No.
Decimal places.
You'll see what that means in a second. Let's integrate first and sub in 1 and 0 and see what happens. Let's integrate this first. Okay, so if I had the integral of, let's say I have just 2x squared and I want to integrate that. We know how to do that. But is it okay to do this?
Yeah.
That's fine, isn't it? I'm going to pull the constant, any constants out, because each term is going to be multiplied by that. So what I'm going to do is I'm going to also pull the constant out of this before we integrate.
Like the 1 over factorial.
Well, let's see what we will pull out. What will we pull out? Well, the factorial 2k is definitely a number. Yeah, and the negative k. Is the sum of all those?
That is a constant. No, because the sum also includes x to the 4th.
Okay. Well, if there was something, let's get a good example here. Let's say we have this. And I wanted to say that this series goes on and on forever, and I want to integrate this. Would it be okay to pull 4 out?
Yes.
But wouldn't it be the sum of all the 4s that I'm pulling out, really?
Yes.
Yes, it'd be the sum of all the 4s that I pull out.
Yeah.
Yes. So I'm pulling out the sum of all these. So that means I can pull out the sum of them. 0. So
You still have the sum of the x to the 4th.
yeah, well, it'd be multiplied. Yeah, it's going to be multiplied. Each one is going to be multiplied by x to whatever the integral is. So now what am I integrating? This is not so bad. I can integrate that. So I pulled out the constants, and what's the integral of this? Yeah, 4k plus 1. Add 1, divide down by 4k plus 1. No. Okay, and I got to sub 1 and 0 into this. Now remember, it's all multiplied by this. I'm not going to rewrite it because it takes a second.
Can you leave your answer?
I'm not finished yet.
I mean, in the end.
What does the question ask for? This is asking for 4. That's for numerical answer to this. So we're not there yet. Right, so let's sub in 1 and 0. What's going to happen when I sub in? What's going to happen when I sub in 0? Let's go to the second one first. What am I subbing in for, k or x? X. Definitely x, yeah. So if this is 0, that's going to be 0, isn't it? And divided by doesn't matter. So the 0 term doesn't matter, yeah? The subtraction. So I just need to sub in 1. That's the only one that's going to matter.
Wait, is it, if it's still going to be 0, it's just x? No, it's 4 times 0 plus 1.
Well, wait. I'm only subbing in for x. I'll sub in for k later on. Yeah, so. Correct. So when I sub in 1, I only have 1 here. When I sub in 0, I have nothing. And multiplying this by nothing will go away. So technically you would have, you'd have the sigma with the 1 subbed in minus the sigma with the 0 subbed in. But we've just figured out the 0 is just going to be 0. Because that's going to be 0. So we're going to ignore the 0 and just look at the sigma with the 1 subbed in. Okay, so k is equal to 0 minus 1 times to the power k, 2k factorial. And that's going to be multiplied by this with 1 subbed in, which you said correctly is just 1 over 4k plus 1. Yeah? Oh, that's right. Like that.
Why is it 1? Isn't 4?
Well, when x is 1, it doesn't matter what the power is. X is 1. Okay, that's what x1 subbed in. That would subtract with x0 subbed in, but we just figured out that that's going to be 0, so we're going to not write that. All right. This is the series that we'll use to get the estimation. Because this is the sum. If I add up putting in 0 in, I'm going to get a numerical value for that first term, haven't I? If I put 0 in, I'll get a number. If I put 1 in, will I get a number? Yeah. And 2 in, I'll get a number. So let's see what those numbers are. Let's sub in 0 first. So we're going to start off, sub in k is equal to 0. What's our first number in this? So negative 1 to the power of 0 is 1, positive 1. So the numerator is 1. What's the denominator? So this is 1. 0 factorial is 1. Yeah, he'll sit down a second. Okay? So the first term is 1. Oh, we can go back into that. We'll go into that another time. We did it when we did factorials back.
Yeah, I remember we did factorials.
Yeah. 0 factorial is 1. Yeah. Yeah, and I did. 4k will go to 0, plus 1 is 1. So multiply by 1. Okay, let's put in 1. Minus 1 in the numerator. This is going to be 2 factorial times 5. Okay. All right, so our first term is 1. Our next term is minus 1 over 10. Are we happy with that?
So why are we doing k0 for one of them, k equals 1?
Because this is what a series is. Series is start at 0, subbing in, and finish at infinity, subbing in. So it will be a while.
No, but why would you do?
So it does converge.
It looks like it might converge.
K0 for both of
Hmm?
them? Why would you do not do k equals 0 for them?
I did. As in, when I subbed in 0, I subbed into the whole thing, and I got this answer. Okay, I'm just subbing in k is equal to 2 here. I'm kind of doing them separately and putting them back.
You did it separately.
No, I did everything. So 2 goes in here and here for this, and here. So what's minus 1 to the power of 2? 1. Positive 1 times 1. And then 2k factorial. So that's 4 factorial. And then 2 here times what? Times 9. So what's 4 factorial times 9? Wow, you're going to need a calculator for that. Or maybe, well, you probably do in your head. 216. 216, yeah, very good. Okay, the next one, I think we're going to need.